Hi everyone, good afternoon. I hope you've had a fun and enriching re:Invent so far. Thanks for taking the time to join this session. My name is Jyoti Agarwal and I'm a product manager with Amazon Redshift. We are here to talk about one of the innovations at AWS Analytics with Zero-ETL and data integrations. Joining us here today are two more speakers, my colleague Harshida and our customer representative from Motive Technologies, Paul. Okay, before we dive in, let's go over the agenda briefly. We'll start by talking more about operational analytics, like what do we mean by it and why do customers actually need it? And then how do customers run such analytics today and the kind of problems that they face? And then we'll talk about how AWS powers customers to run such analytics through Zero-ETL and the kind of innovations that we've done in this space. And then Harshida will do some deep dive demos as well as use cases and patterns that we are seeing our customers adopt with Zero-ETL. And finally, Paul will bring it all together by sharing the journey Motive has had with Zero-ETL and the results that they are experiencing. Okay, data drives innovation, right? We are seeing that more and more enterprises are becoming data-driven and are using it as a source of competitive advantage. So much so that data is no longer confined to back office operations and underpins major business transformation initiatives like the ones shown here, like anomaly detection, gaming leaderboards, or threat detection. And additionally, with the advent of Gen AI and machine learning, there's more emphasis on getting the right data and at the right time. And organizations like yours spend a lot of time and effort in getting this data and building these data pipelines. However, what we've heard is traditional ETL approaches don't always meet these requirements. Okay, by a show of hands, who here has a need to run operational analytics or analytics on their enterprise data? Come on, don't try. Yes, quite a few of you. Okay. Also, by show of hands, who here has the requirement to maintain and build these data pipelines? Well, sorry about that. You all are the reason why AWS is continuously investing in a Zero-ETL future. We want to make it simple and reliable and want to remove the data replication pipelines to give you access to your data so that you can focus on generating insights out of it. At AWS, we have a purpose-built data strategy to give you the right tool for the job when it comes to storing and processing your data. We have the broadest and deepest portfolio of databases to meet a variety of use cases, whether you're looking to modernize your application or just to move to a managed application. We support both relational databases such as Amazon Aurora and RDS and non-relational ones such as Amazon DynamoDB, DocumentDB, and MemoryDB. We also have a purpose-built cloud data warehouse to provide large-scale analytics, which is Amazon Redshift, which sits at the center of your data journey. It is a fully managed petabyte-scale data warehouse that's deeply interconnected to all our data offerings to deliver the best price performance in a cloud data warehouse. Now, all these purpose-built systems generate a lot of data that you'd want to run analytics on in the powerhouse of Redshift. Which brings us back to really, why Zero-ETL? Well, customers like yours, they tell us that, hey, today, to run analytics on all this data in Redshift, what we do is we have some homegrown ETL solution for which we write scripts or configure APIs and add some data correctness checks and multiple other bells and whistles just to land this data in the warehouse. Or they use some existing third-party tool that does this job for them. However, these approaches don't always work, and because they are not built to last. So they tell us that, hey, it's a lot of operational overhead in building and maintaining such tools and pipelines. And God forbid, if anything breaks, in addition to being paged in the middle of the night, by the time you are getting everything back and up and running because of so many hops and so many touch points in the middle, the data is almost stale by the time it lands in the warehouse. And it's almost unfit for consumption. And we are not saying that you should absolutely abandon your data pipelines. Well, there are many, many compelling reasons to continue to build data pipelines and use the ones that you already have. For example, if you want to run streaming analytics or have a use case to send same data to multiple downstream applications, you should continue to use your data pipelines. But if all you want to do is run analytics on all your data in Redshift, Zero-ETL is fit for you. It is a fully managed tool by AWS that's purpose-built. It is secure, accurate, reliable, efficient, and performant. To create the integration, you can choose the method of your choice, from Amazon Console to CLI or the integration APIs, and the integration gets created within a few minutes. Yes, minutes. And our system handles all the DDLs and DMLs for you, and we also have inbuilt monitoring and observability so that you have more insights into what's actually going on behind the scenes. And the entire system can be made serverless, so we handle the data fluctuations without infra management. And now we've been doing this for a while, right? Just removing the muck out of moving data or making data pipelines and going towards a Zero-ETL future. Over the past couple of years, we've added Zero-ETL from Amazon Aurora MySQL and Postgres, RDS MySQL, and DynamoDB. And yesterday, Matt Garman announced Zero-ETL for applications, the fully managed solution for SaaS applications such as Salesforce, SAP, ServiceNow, and Zendesk to both Amazon Redshift and the newly announced SageMaker Lakehouse. With this launch, Amazon Redshift now supports 12 different Zero-ETL sources, enabling you to run combined analytics from all your operational databases as well as applications in the same Redshift warehouse. Zero-ETL for applications, it removes the need to build data replication pipelines by combining ingestion and replication into a single process and incorporating best practices for full data sync, detection of incremental updates and deletes, and target merge operations. Integration maintenance is automatic, so it removes the operational overhead from your data engineering teams. With that, I'd like to share some of the customer references that we have on Zero-ETL. The first one is from FirstCry. That's a leading e-commerce platform for children's product in India. They're using Zero-ETL between Aurora and Redshift to run analytics on top. And before moving to Zero-ETL, their SLA was 15 seconds. But since they made the switch, the SLAs have gone down to 120 milliseconds. That's a 99% improvement, definitely transformative. The second one is from Verisk Analytics, a leading analytics company that provides solutions and services to various industries. They're using Zero-ETL from DynamoDB to Redshift. And as we can see from this quote here, that earlier they had some homegrown solution which would often time out, causing them a lot of operational pain. But they've had a significant improvement in their experience since switching to Zero-ETL. And with that, I'd like to invite Harshida on stage for the next session. Thank you.
Thank you so much, Jyoti, and thank you all so much for joining us today. We'll now dive into how Zero-ETL works. We'll start off with a relational source, NoSQL, application, and then we'll walk through some of the patterns that you can consider and the customers are using with Zero-ETL integration. So in order to create a Zero-ETL integration, you need authorization. This authorization is based on IAM policy. Once you have the authorization, you can create Zero-ETL integration using AWS Console, CLI, or API. When you create the integration, you specify the source and the target and few configuration. Once it has set up, it starts replicating. In order to monitor the status of Zero-ETL integration, you can use Amazon Redshift Console, you can use AWS CloudWatch, and you can also use Amazon Redshift System Views to monitor the status of the Zero-ETL integration. Now let's start off when you have your source as a relational data source. It could be Aurora, MySQL, PostgreSQL, or RDS for MySQL. And the destination is Amazon Redshift. You have created the pipeline. So first, you specify the source. In this example, we are going to use Amazon Aurora, and the destination is Amazon Redshift. You have set up that pipeline. So what happens and what are the things that Zero-ETL takes care for you? First is seeding the data. Consider this as the full load or the initial load. And this occurs from the snapshot of your source database engine. The second is identifying the change data capture. When you make inserts, updates, deletes, or you're adding a table on your source or dropping columns, all of these changes are detected from enhanced bin log. And those changes are replicated onto Amazon Redshift. You also have the ability, if you need to reseed or fully load a particular table, you can choose to do that using an alter statement on Amazon Redshift. And a lot of times customers do ask, we don't want to replicate all the schemas, all the databases, all the tables. So with Zero-ETL configuration, it provides you the ability to apply data filters when you can include or exclude certain patterns so that you can limit the number of objects that are being replicated. Now here is an example of Aurora PostgreSQL, where you will see the objects with a hierarchy of a database, schema, table. Correspondingly, on the Redshift side, you will see database, schema, and table. If there is a row which is inserted on your source, that change will be replicated on your target. If there is a column which is dropped on the source, the same change is reflected on the target. One integration can have n number of schemas, n number of databases, n number of tables, but you control the configuration. As well as if there is a maintenance operation, be it on your source or on your target side, Zero-ETL, when it's doing the change data capture, it keeps track of the checkpoints. So it is resilient to all of these maintenance changes. Now let's dive into the demo. This demo, we are going to use Amazon Aurora PostgreSQL, which is already created, and the target, Amazon Redshift Serverless, which is also pre-created. So let's walk through this demo. The first step is to go to RDS console. And in this Aurora Postgres data, there is a database with two tables, department and nation. When we set up the Zero-ETL integration, we only want to replicate department and exclude nation. There is also a pre-created Amazon Redshift Serverless, Zero-ETL, which is the namespace. In order to create, we are going to use AWS Console to create the pipeline. So let's go ahead and create Zero-ETL integration. We'll give it a name, Aurora Postgres Zero-ETL Demo. We'll go ahead and do next. And this is where we would specify the source. It would only list the source which are compatible. So we selected, and now we are going to apply the filters, the data filters. We want to include all the tables and exclude the table nation from the replication. Now we will select the target. The target, Amazon Redshift, could be in the same account, or it could be across a different AWS account. For the purposes of the demo, we are using the same account. When you are doing this configuration, this wizard identifies what are the missing configuration. And when you click on Fix It, it's going to create the authorization or resource policy, as well as it's going to set the case sensitiveness on Amazon Redshift. So we'll review this, and let's continue. You can apply tags, as well as you can bring your own key for encryption. Finally, we'll click Next. We'll review the configuration and say Create Zero-ETL Integration. Once the pipeline or integration is active, the one step which the wizard will walk you through is to create a database on Amazon Redshift. This is the database where all the tables will be created and the data will be replicated. So let's go ahead, and we will create a database on Amazon Redshift. We'll call it Zero-ETL DB. So the source is Zero-ETL DB, and the target database, you can give this database any name on Amazon Redshift, but for the purposes of the demo, we'll call it Zero-ETL DB. As soon as this database is created, the replication, the seeding, the change data capture starts. And you can review the status of this integration on the console, where the lag is 5 seconds, the number of tables replicated is 1, and you can also look at the table statistics. So department table has been synced. So this has already created a table on Amazon Redshift. The data is already synchronized. Now we'll log on to Amazon Redshift using Query Editor v2. We'll navigate through the Database Explorer, click on Public Schema, and the table department is available. The change data capture, or Zero-ETL, also takes care of data type match or data type conversion. Now let's go ahead and query the table department, where we are able to see the records which are replicated. And when you want to monitor the status of Zero-ETL, you can use the system view. The system view gives you information on the checkpoints, the duration of the checkpoints, as well as the type of how many records or rows were inserted, updated, or deleted. So this summarizes the relational data source. What if you have a NoSQL Amazon DynamoDB as your source? You are using it for transaction, and your destination is Amazon Redshift. So we select the source, Amazon DynamoDB, and the target, Amazon Redshift. If you use the wizard, it would enable point-in-time recovery on Amazon DynamoDB. This integration is using DynamoDB Export API. So the data gets unloaded to S3, Amazon S3, and then the integration or incremental updates happen on Amazon Redshift, so that the DynamoDB is not impacted during this replication. So it uses DynamoDB Export API. Again, with this integration, first is seed the data, subsequently change data capture, and finally, you can also consider to reseed it. In this example, DynamoDB, there is a table music, the partition key is artist, and the sort key is song title. The table which is created on Amazon Redshift, it has the same name music, but the distribution key is the partition key which is artist, and the sort key is the song title. If DynamoDB has the other attributes, they are stored as in the column value, which is of super data type. So now, change data capture, you can reseed. And this is an example of an item on DynamoDB side. And DynamoDB does not have a concept of a database. So when you are creating the integration, you include a table, DynamoDB table per integration. So the item is artist, song title, genre, and rating. And this is how the row gets reflected on Amazon Redshift with the column artist, song title, and the value, which is in semi-structured JSON format. So let's summarize this. When you have relational source versus you have NoSQL, if you want to be selective, you can apply data filter. If you want to control the cadence through which this replication can run, you can use refresh interval. You can choose from 0 all the way to 5 days for the relational, versus on DynamoDB, you can choose from 5 minutes to 5 days. Consider a scenario you don't want constant replication, or you might want to only replicate this data once a day. This refresh interval allows you to control that. When the data lands on Amazon Redshift, you can use all the features on Redshift. And one such feature is Materialize View. Materialize View, say you are joining tables, you're aggregating, and you create a Materialize View using that, it physicalizes this data. When the underlying tables changes, Materialize View are incrementally refreshed. So this again helps with your pipeline or the ELT integration. Zero-ETL tables are read-only, but it allows you on Redshift, you can run an alter table statement to specify a sort key. This specifically helps you to improve your scan performance. The key consideration when you're using relational versus you're using NoSQL is the lag. With relational, the lag is in seconds. With DynamoDB, the lag is 15 minutes to 30 minutes to replicate the data. Now let's look at the recent announcement where it allows you to have your applications. It's a SaaS application, which allows you to do Zero-ETL using AWS Glue, and the destination could be of your choice. The destination could be Amazon Redshift or Amazon SageMaker Lakehouse, and you can use the storage of your choice. If you choose Amazon S3, the tables are replicated and they are in Iceberg table format, cataloged in Glue, or you can use Redshift Managed Storage as native Zero-ETL. Now let's look at this demo. So first, we are going to go to the Glue landing page and select Go to Zero-ETL Integration. We'll create Zero-ETL. Similarly, we'll specify the source as Salesforce, and we'll click on Next. For Glue, it requires a connection, so it can extract the data from Salesforce. So we are going to specify the connection, and then we are going to give an IAM role to Glue, and then we start selecting the entities that you want from Salesforce. We'll select Account. The console also provides you to do a preview of the schema as well as data preview. So you can look at the preview of the data. Once we have selected account, we'll go ahead and select additional entities, customer, opportunity, campaign, and contact. So we'll select opportunity, followed by campaign, and then contact. As soon as we have selected this, we will select the destination. The destination can be same account or a different account. You can use Amazon S3, SageMaker Lakehouse, or Amazon Redshift. So again, Fix It For Me creates the authorization policy and sets the parameter group. We'll go ahead and name this the integration Salesforce Zero-ETL demo. And then we'll click on Next. Once we'll have reviewed the configuration, we will create this integration. As soon as the integration is created, it's in the active status, but the replication would not start unless we create the database on Amazon Redshift. So this wizard is going to guide us, and we are going to create database Salesforce on Amazon Redshift. So we'll specify Salesforce and create the database. Before we start querying this data, we will review the status of this integration using the console, where it shows the table, number of tables replicated is 5, and then we'll look at the table statistics. And what we want to see is all the tables have been synchronized and are available on Amazon Redshift. Let's go ahead and log on through Query Editor. And then we'll expand the database Salesforce, public schema, and we should be able to see 5 tables which have been replicated and created in this database. So as the underlying data or the Zero-ETL pipeline is continuously updating and replicating the data, you have the ability to start running analytics on this table, use integration, or transform the data. So here is an example and sample records of the tables which have been replicated. So we reviewed the Zero-ETL integration, how it works with relational, NoSQL, and application. Now let's review some of the patterns that we have seen customers use with Zero-ETL. Say you are starting your journey with Amazon Redshift, or you have a need to replicate your operational source, which is relational, you can use Zero-ETL. If you have a need to do transformation on this data where you want to integrate or you want to combine to the tables which are already existing on Amazon Redshift, you can use incremental refresh with materialized view, or you can also use tools of your choice, be it dbt, AWS Glue, or Amazon EMR for in-database processing. If you have a need to add further more additional sources, say you already have orders data, but you want sales data to also be replicated onto Amazon Redshift, this is where you can be selective. You don't want to replicate all the tables, where you can apply data filters. In this example, you are including all the tables, but specifically you want to exclude all the sales tables that have the prefix external. Now you're further adding more sources, and now we are adding Amazon DynamoDB. As we reviewed in the slide, the integration or the lag is 15 minutes for DynamoDB versus for relational sources, it's 0. When you want to do integration, you want to ensure that the data arrives at the same time. So if there is a column or a key that you want to look up from the relational and join it to the attributes from DynamoDB, they have to synchronize at the same time for you to build your pipeline. And this is where you can apply refresh intervals so the data or the replication is occurring at the same time. In this example, we are using 1 hour. Now you're adding additional Zero-ETL from your application. In the demo example with Salesforce, we selected customer and contact. Both of this table have personally identifiable columns, which you want to mask them. You want to redact the information before the users are querying it. As these tables are landing on Amazon Redshift, you can use role-based access control in Redshift, apply the dynamic data masking policy on this table/column, so when the end users, based on their role, when they are querying it, those data is redacted. Now let's consider you have an existing ETL pipeline. You have your sources, you want to replicate, or you want to bring this data and apply the incremental changes on Redshift. Say, for example, when you have a traditional process, either you are fully unloading the data from your source onto Amazon S3, you are truncating the table on Redshift and doing a full load or a full copy every night. Or you might be using a serverless pipeline where you are capturing change data capture using AWS Database Migration Service, might be using EMR to transform the data or curate before you apply those changes onto Amazon Redshift. Or you might be using Debezium to capture the changes, using Kafka to replicate it, and then using a sync connector to apply those on Amazon Redshift. All of this can be simplified by using Zero-ETL integration. And now, because the data is on Amazon Redshift, you can leverage all the functionality within Redshift, which includes data sharing, which allows you to scale both your reads as well as write. You can do data sharing between Amazon Redshift Data Warehouse, within AWS account, across AWS account, and across AWS regions. When you do data sharing, it is secured, there is no data duplication, and it provides you live transactional consistent view of the data. Now let's summarize all this. We reviewed the Zero-ETL integration from relational, NoSQL application, but what if there is an event-driven and the data is arriving on your Amazon S3? This is where you can leverage Amazon Autocopy or S3 Autocopy, where you create a copy job. Say, for example, you create a copy job. There were 100 files which were on a particular S3 path. Those 100 files got loaded into a table. Say within 1 hour, you received 20 more files. With Autocopy, it's only going to load only those newly arriving files, so Amazon Redshift is the one who is keeping track of the checkpointing. If you have any sources which are event-driven, IoT or web logs, and you're using Amazon Kinesis data streams, Amazon Managed Streaming for Apache Kafka, or you might be managing your own Kafka or using Confluent, Amazon Streaming Ingestion integrates with all these sources where the data is pulled into Amazon Redshift. So with all these features and all this capability, it allows you to break the data silos. You can integrate the data, provide a unified view, and you can scale your analytics, both read and write using data sharing. You can open up the access to your end users who are using different personas, different products, and this is the data foundation that helps you build your generative AI experience. I'll now like to invite Paul to walk us through Motive's journey. Thank you. Oh, sorry. I was going to walk away with it.
Walk on stage, walk on stage. Hey folks, I'm here from Motive, and what we do at Motive is really just power the physical economy. So what that means really is we've got quite the suite of products and tech that really run the gamut. A big part of what we do is we have an AI dash cam, omnidirectional cam, sensors, etc., to check driver behavior, collision detection, a lot of things for driver safety, driver coaching, with a lot of AI models built in-house, everything on AWS. And with all that data, there's a lot of fleet management and using all that data for safety and compliance that all these companies with fleets need to manage on massive scales for tens of thousands of vehicles. And the tracking and telematics that go along with it, locations, trips, all these types of things, and spend management. So we actually provide credit cards and the capabilities to track and manage spend across these fleets, which brings us to what we're going to talk about in a bit. A little about myself. I've been running kind of global SaaS for almost 20 years now, which feels weird to say. But in my free time, I do like to push the limits a little bit, a little paragliding, a little free riding, and that may lead me to kind of push our teams and push the tech a bit. But really, at the end of the day, it's our platform teams in platform engineering at Motive that really make all this happen. Everyone from our infra and SRE folks to our database engineers, security teams, our developer productivity, DevOps world, our IoT, which use AWS's IoT core to interface with over 1 million vehicles out in the field. Our application architecture that interfaces with all our product services teams, the libraries, and runs our vehicle gateway pipeline for all this event data. Our ML platform folks and our data platform team, which uses a lot of the tech we've been talking about today and really drives this push. So when it comes to the spend management and handling these transactions, one of the great capabilities of us having all this data together amongst the fleets is we're able to use this data to help prevent fraud, to protect companies as well as ourselves. And we're able to do that with location data. Is that card transaction happening anywhere near where the vehicle or the driver that it's supposed to be at? Did the fuel level actually go up if they purportedly bought fuel, right? So seemingly simple things, but you need the data, you need the tracking to be able to do these. And so we do this in a couple of ways. There's real-time blocking right as a transaction comes in, and as well background detection, which can be 6+ hour kind of analytical time frames, part of which is due to data sync timing, which we'll talk about. And then we do a lot of model training and analytics on this massive amount of data to kind of advance all of our strategies and tech with helping improve these fraud rates and prevention. So source data. We're heavy on Postgres here, RDS, and basically moving everything to Aurora that isn't already. And our fuel events and transaction data is all Postgres. So we started with a modest use case, though important, which this is only 11 terabytes. We have ones that are hundreds of terabytes and running about 1 gig a day. Number of different data formats, right, in these tables and columns, varchars, timestamps, etc. A note on those varchars, like under 65,000, right? There's a limit, so to help the sync happen. And we also have a number of DynamoDB tables In this case, we're using our location metadata and other profiling data, which is mainly JSON, geolocation data, etc. For reference, our main location data, this is outdated now already. We're approaching 300 terabytes. There's a 100 terabyte limit for Zero-ETL, so it's too big for now, and we're probably moving that to OpenSearch anyways. So what does that look like for us? So like many folks, organic growth comes with a lot of spread. So we've got our relational data for the services up top, and really our data platform layer at the bottom. And what you can see there is a number of different ways to get data from our sources over. So over time, we have everything from basic S3 loading that we do use Redshift for and load in there, but we also have Airflow jobs to get that into our external data warehouse that is large, as well as having sync connectors off Kafka to get it over there. We use an external connector vendor for hooking up Postgres and Dynamo and other sources. And then we started rolling out Debezium instead of that external vendor for kind of better syncing. And even though everything's containerized and codified, there's still a fair amount of setup with Debezium. And so we have, a number of different ways just to get data there. And if you'll notice this little dotted line up here, we're even shipping data back out of that external warehouse back into Postgres, because for those high frequency, low latency transactions, our in-app use cases just can't use that external warehouse for those kinds of use cases. So after all that moving data in, we still sometimes have to move it back out just to use it. So quite a jungle, you could call this. So complexity is there, as you can see. The cost gets out of control, especially moving this much data in all our use cases. The network costs for data moving alone is huge. Never mind all the vendors, the other running the connectors, and so on. Our cadence processes for these, they range anywhere from 45 minutes usually for our Postgres tables, that they're on a 30-minute cadence, but it takes 18 minutes or so for them to actually run. So you're looking at almost 50 minutes, and then 3 hours, 6 hours on our Dynamo tables for most things right now. And the maintenance is just huge. Tuning and sizing connectors, the setting up a Debezium, multiple teams, our data platform team, our database engineers need to set up replication slots, and everyone's got to coordinate to make sure it actually works. And then the visibility into it is just, did the table fail or not? What's the actual latency going on? We find out, later. There's a lot there and a lot of challenges thus far. So our goals, obviously, simplify. The fewer sync methods we need to run, the less there is to do, the less there is to go wrong. We need to get more into streaming, right? Our enterprise customers want their data, want their reports more and more, like as real time as possible, right? Not 6 hours plus. And obviously our detection for fraud needs to be as quick as we can get it, right? And being able to support that direct app usage, not needing to ship data around again, just be able to use it in app in like high frequency cases. And saving costs anytime we can. That's a bonus, right? Good for business, and also good for prioritizing projects and getting collaboration, right? Because it raises that priority. So yeah, Zero-ETL to the rescue. Once we heard about it, it's very cool. Let's get into it. And tight integrations with everything we were using: Aurora, RDS, Postgres, MySQL, Redshift, etc. The compliance is easier, right? We're not having to worry about our data being in 3 different locations, a couple of external ones, who has access to what data. It just makes compliance easier because everything's internal. And so then as we started getting into actually setting it up, then we start seeing the ease. So you saw in the demo, it helps guide you through, right? You need this set up. Oh, point in time recovery isn't set up. You're living on the edge. What permissions are needed, what might be needed to just get it set up, and it can actually fix it for you. So this made it just that much easier for not just our data platform team, but our database engineers. Anybody could really get this set up. So that was really nice. I didn't have to rely on kind of a couple of our specialists. And the filtering that you saw, include excludes, for us especially, being able to include future tables is huge, right? It doesn't mean more requests coming in. Can you add this table? Can you add this one? It's just less and less work we actually have to do to keep everything in sync, which is more time and everybody's happier. So these things have been great for us. So I'll look at the jungle again, what we've been dealing with. And then after getting Zero-ETL in there, with that bit of magic, you see the simplification. I mean, it really speaks for itself. So much removed. We're just pointing Postgres, MySQL, Dynamo at it, and it shows up, right? And as we move things to MSK, we're able to point that at it and skip other loading out or into S3 or sync connectors out. Just all these things removed. The simplification is really wild. So I like it when my diagrams are easier to look at. So it's a nice one. Yeah, so the results. As you saw, 4 sync methods down to 1. That's pretty huge. And no expertise needed either, right? I don't need Debezium experts or connector tuning experts or this or that. The latency, massive change, right? 40 minutes, 45 minutes, down to 15 to 30 seconds, right? With nothing for us to have to do or tune to get that kind of number is amazing. And those 3-hour plus syncs on Dynamo down to 15, 20 minutes. Yeah, amazing. This is huge for our data needs, right? And it opens up possibilities that people can do with the data as far as reporting or use it more real time rather than saying, oh, we can't do that because it's 6 hours delayed. So not just a latency win, but feature win for us. The effort, just wildly less, right? Provisioning is a breeze. You've seen it in the demo. That's really all there is to it. And the visibility. So we would just know maybe if something broke or didn't run or not at best. Before, that was kind of it. Now we have our latency times there. We have row counts, etc. And we're able to, put that into all of our monitoring solutions from CloudWatch. So everything just got easier and more visible for us, which means we can keep an eye on things rather than people letting us know, like, hey, wait, I don't see data from today and we have to go check it out. So that helps a ton. And then cost. Well, anytime you simplify or take things out or aren't shifting data all around, obviously cost drops. And so we save about $10K a month. Just even on some of these somewhat smaller use cases, because we're just getting rid of connectors, we're getting rid of data transfer costs. The compute to load data into the warehouse is gone, right? It's not consuming Dynamo read or write units, it's not consuming Redshift CPU, any of this to load it in. It's just happening, right? So a lot removed, not just sync methods wise, but actual processing. So I don't know how AWS handles it, but it's magic to me and cost savings for the business. So what's next for us? Really, Zero-ETL, all the things, right? So we're migrating everything to MSK, basically not just for cost savings there, but because of the capabilities, right? We can do this So everything we move gets this capability, which just opens up a whole new world of less work and faster data for us. And of course, for Postgres, since most of our world is Postgres, you need to be on the latest minor version of 16 to be able to do Zero-ETL. So we should upgrade anyways. Now we have good incentive to do a lot of upgrades. And talking about use cases, our main vehicle message pipeline is a 30 terabyte Kafka topic, running 200 plus megabytes a second through it. And so this is going to be a huge one for us as we do a lot of that. So you saw kind of that message parser and dumping to S3 and into Redshift and the external warehouse, all that. Putting Flink ahead so that we can get the data in the format we want going into Kafka so that we can Zero-ETL it out and not have to change anything or check dedupes or any of that stuff is going to be a huge one for us. So prepare our data and basically prepare it so that we can use Zero-ETL to do that magic transfer for us. And in that POC and our run through, that is going to save us about $750,000 a year from not having to load data in, do data copies and transfers and all this stuff. So this really is huge tech for cost savings, ease, everything. It's pretty wild for us and puts it at the top of list of projects because of the numbers. But the benefits of the latency are even bigger for the business as far as data goes. And then the SageMaker Lakehouse, we previewed and was excited to see the GA and really waiting for that is awesome because with Iceberg, it eases our migration, right? We're able to, for the use cases where we're migrating data into Redshift and Zero-ETLing it in there, but some of our analytics may need to still access data sources that we haven't migrated yet. Exposing it via Iceberg allows us to query it from either place so that we can have a kind of an ease of migration. We don't have to like get everything ready and do huge cutovers of everything. So being able to expose shared tables or Zero-ETL tables via Iceberg and do that means, yeah, we also have an easier time doing this whole thing, which is always good and less stressful for us, which is what we want at the end of the day. Yeah, and I don't know, people always ask about data quality every time we look at these things. So for us, we just spun up open metadata. And while we have that visibility into number of rows, natively from the Zero-ETL integration and so on, with open metadata spun up, we're starting to make some actual data quality checks for the lineage that'll really help us, kind of finalize our surety here. So we also need to get that in place as well to really up our game. But yeah, exciting stuff, huge cost savings, and just lots less work for us to do. So happy to do some upgrades to get all of it. Yeah. All right. With that, it takes a team, a bit of magic, in this case Zero-ETL, but really it's all about the team. So a huge thank to the team at Motive, our data platform team, especially Tianyao Zhang, and our database engineers, Glenn Zhu and Alex Konovalov, and all the other teams involved with making this happen, and our AWS team for cluing us in to what's going on, getting us into previews, and helping us through a lot of the POCs and how we can use it. That really just helps us have an easier time to make this all happen. So a huge thanks to all these folks that really make the dream come true here. All right. So thank you all. And please take the survey as you can. There's supposed to be a QR code somewhere. No. Well, there's a QR somewhere in the mobile app. Yeah, thank you so much.